Hi, Doctor and everyone. My name is Nur Tasha binti Muhammad Saleh. My metric number is U200-5182. And today, I will talk about homeostasis of thermoregulation. And what is homeostasis and thermoregulation? Homeostasis is defined as maintaining the steady states inside the body, while thermoregulation is defined as maintaining the internal temperature of the body. Temperature regulation is type of homeostasis and it means of preserving a stable internal temperature in order to survive. There are two types of thermoregulation, which are ectotherms and endotherms. Ectotherms are animals that depends on their external environment body, while endotherm animals that use thermoregulation to maintain a consistent internal body even when their external environment is changed. Human is endotherms. The normal internal core temperature for human is 37 degrees Celsius. This is the optimal temperature at which human body system function. There are many factors that can raise and lower the internal pressure. The factor that can raise the internal temperature is fever, exercise, and digestion, while the factor that can lower our inner temperature is drug use, alcohol use, and metabolic conditions such as underfunctional thyroid gland. Thermoregulation has three mechanisms: efferent sensing, which are efferent response, control center, and efferent response. There are receptors in our body for both heat and cold that can sense heat and cold throughout our body. Efferent sensing works through this receptor to determine if the body core temperature is too hot or too cold. And the hypothalamus is the central controller of thermoregulation, while efferent behavioral component is response or effected in body temperature. In a easy explanation, that efferent sensing acts as receptor, control receptor acts as hypothalamus, efferent response is an effector. Next, the brain, more specifically our hypothalamus, will sense the control thermoregulation. It senses if our temperature is too hot and too cold, and it will send the signal to our effector, which are skin, gland, and muscle. Next, I will move to the process of the thermoregulation. This is when our body temperature drops, our hypothalamus initiates several physiological responses. It will increase heat production and conserve heat to keep the body warm. Our body will start to increase the production of heat by shivering. Next, the vasoconstriction occurs, which is the blood vessel under our skin become narrower. This decreased blood flow to our skin will help to retain heat near the warm inner body. Adrenal glands secrete stimulatory hormones such as norepinephrine and epinephrine to increase metabolic rates and hence heat production. This effect causes body temperature to increase and back to normal. Hypothalamus is no longer stimulated. Next, I will talk about when the internal our body is dry. Hypothalamus initiate the several physiological response to decrease heat production, and it will send the signal to our body. First, the widening of surface blood, which is vasodilation. Blood under our skin get wider. This increase blood flow to our skin where it's cooler, away from our inner warm body. This let our body release heat through heat radiation, and our body will start to sweat. Our sweat glands release sweat, which cool our skin and as it evaporates. This helps lower the internal temperature. result in our body back to normal and decrease. And then the hypothalamus is no longer stimulated. Last but not least, thermoregulation is crucial to human life. Without thermoregulation, the human body would cease to function. Thermoregulation also plays as an adaptive role in the body response to infection pathogens. Or we can see that in summary that body temperature falls, the blood vessel constricts, sweat gland do not secrete fluid, and we start to shiver, and our body will back to normal. And when the body temperature rise, blood vessel dilate, sweat gland secrete fluids, and we start to sweat, and the normal body back to normal. Thank you. That's all from me.